So we're going to be talking about the overview of how a network is actually structured. As you can see right here, we've got a workstation, we've got some switches and routers, we also have a server, and it connects out to the internet. So at the home campus, you actually, if you were to walk into any of our computer labs, obviously all those computers are networked together with cables. But room by room by room, they're then connected by routers or switches, depending on their location on campus, and they will go through our online or Wi-Fi network to connect to further routers and switches that then hit up the network, the internet. Printers themselves are becoming wireless. You might even have a wireless printer at home. The server that's listed right there can also be known as a web server. Many people have already actually moved over to Amazon Web Services or Google Web Services, and they're housing their websites instead of on local web servers. They're actually housing it out on cloud web servers. So a local area network is going to be basically one that I just mentioned within an actual building or within a small group of buildings, much like the Joliet campus of JJC. That's a local area network. Or the Romeoville campus of JJC is another local area network. When we start connecting between different cities or towns, that's going to be considered a wide area network. So again, connecting Romeoville campus of JJC to the Joliet location of JJC, that's going to actually span across a wide area. Thus, we are running a WAN in that situation. Larger than that is even something called a MAN, which is a metropolitan area. That's across larger than just city by city, but maybe across larger areas like the city of Chicago. The backbone of the internet has an infrastructure. Oftentimes it's run by, again, switches and routers that are able to connect or interconnect our requests from different web servers from the device that you and I are sitting on at our home computers or in the computer labs at school. And when you search for, let's say, target.com, you type in that domain name, it then gets switched over to the IP address. It seeks out wherever that web server is located. The web server says, oh, this person's looking for an actual web page. So they return that web page and they send it back to the web server to then send back to you utilizing the MAC address on your actual PC. So there's a link there if you want to check out the internet backbone of the internet. Cisco services is oftentimes the backbone hardware that's used to interconnect all of the different devices across the internet. The client server model that you see listed right here, the client is going to be you sitting at your PC, and the server is, again, where you're requesting it from. And what we see right here in this image is that the server is this box. It really is. It's just simply a computer itself. It's nothing more than that. But on the same token, it could be a massive rack of different servers that are housing lots and lots of requests all at the same time, not just a simple little PC. And oftentimes these are going to be housed in Amazon Web Services or on a cloud server, not necessarily in the closet of a building or structure. It's all very dependent. So when we go to access websites, we utilize what's called a web client, and so we're going to be running a web browser such as Internet Explorer, Firefox, Chrome. By the way, Chrome is the preferred browser for you to access Canvas, which is where all of our course files are located. I oftentimes will be using Canvas when I'm actually testing out your web pages, so keep that in mind when you are developing your web pages. Internet Explorer is actually phased out. They now have the Microsoft Edge browser. Chrome is still the preferred browser across campus, across most clients, etc. So the HTTP that you see listed right there is the Hypertext Transfer Protocol. Now, protocol is a set of rules or instructions in which something must follow. So in the case whenever a web browser sees HTTP:// it basically says go do a request of whatever the domain name is, like www.jjc.edu. In that process, the web server then receives that request, transfers it over to an IP address, sends the request over to the server that's housing that actual web page. And once again, the packets of data that are sent across do keep information as to who is doing the request, so utilizing a very unique MAC address on the device that you are doing the request from, albeit your iPad, a PC, a computer in the lab, your smartphone, etc. It keeps track of that information, packets of data. It retrieves the home page if it's available, and then it sends it back to that MAC address. Sometimes you might see a 404 page not found error. And this is again just because they can't find that particular web page, and so they send you that error. And then sometimes if you refresh the page, magically it appears. Well, in the process of doing so, possibly when it was requesting for that web page, the server that you got to, or the router or the switch, we'll stick with the router, sent you on a pathway that maybe wasn't up and running. Maybe the actual server or router died, and so it's no longer functioning, and so that request didn't go all the way through, and so it times out and sends you a 404 error, page not found. The switches are smart devices which will try to find a different pathway to find that actual page that you're looking for. All right, MIME types are referring to a multi-purpose internet mail extension. Basically, whenever you download, let's say, an image, a JPG, a GIF, a PNG, somehow your computer magically knows to say, hey, do you want to open this up with Microsoft Paint, with Photoshop, with an artistic tool, etc. That's the MIME type. So the computer knows what types of applications can best open the files. Likewise, if you download, let's say, a DOC, a doc file, or DOCX, by default, your computer might say, I'm going to use Microsoft Word. Obviously, you can change it and have it open up in WordPad or Notepad or whatever application you choose. But that being said, that's what the MIME type is referring to, is a set of information to always open up a particular file with a particular tool. All right, protocols, like I said, protocols are a set of rules or instructions. Check out these in the textbook, the file transfer protocol. This has two different rules. You either get a file or you put a file. Those are the only two rules within the FTP. There's email protocols when you are sending an email. The SMTP, Simple Mail Transfer Protocol, is there to say, hey, listen, Angela is sending an email to bob@yahoo.com, and when the mail server sees that it's going to @yahoo.com, it'll go to that server, say, hey, is there an email out there called bob@yahoo.com? If the server says, yep, there is, then my email goes through. And if the web server or if the mail server says, nope, no such email address, it rejects it, and I get a mailer daemon error in my inbox that says, hey, listen, we tried to send this to this email address that you provided, but there's nobody in that particular email address, so we're sending it back to you, and that's called a mailer daemon. Two other protocols about mail, check those out, POP3 and IMAP. Okay, so we talked about HTTP. TCP/IP was Transmission Control Protocol, Internet Protocol. Basically, this is that conversation of, hey, let's send packets of data out to retrieve the actual web page you're looking for. As I said, these are going through in packets. It also keeps the source, that's your MAC address. It knows the destination, which is the IP address. Then there's something there called a checksum that says, was the page found or was the page not found? Because the page wasn't found, aka that 404 error, the checksum gets triggered to negative, and then that's when you get the 404 error code. That's not specific to the actual website. It's a generic 404 error, as in I cannot find the web page. So this is that process of request and response. All right, Internet Protocol is referred to as an IP address. Typically, IPv4 has 4 different sets of numbers separated by periods. There's also something called IPv6, which, due to the fact that we're running out of IP addresses, IPv6 was created and is running in Europe, and slowly but surely the United States is coming on board with IPv6. But basically, as I said before, it separates 4 numbers between 0 and 255. And so you can see right there that this is the 216.58.194.46 is the IP address for Google. Or so it says. IP addresses can oftentimes change. They're dynamic. You might have an IP address on your home internet right now that's different in 3 weeks because they're set up to purposely be dynamic and change over time, so that way people don't run different types of web servers out of their homes that are inappropriate or aren't designated as a business site, so therefore they are set up to be dynamic. So you can always do an IP config and check to see what the actual IP address is for a business, a computer, or your own internet at home. All right, this is referring to the Uniform Resource Identifier, which is a URI or URL, where it says the HTTP, that again is your protocol that tells the web browser it has a job to do to send a request and receive a response. The domain name is the Web Dev Foundations that you see right here. The .net is going to be your top level domain name, so .net, .com, .org, .museum. Those are all different types of top level domain names. Then we see a / separating the actual domain name to a folder name. That's where we see chapter 1. And then there's a / to separate any folder name or multiple folder names separated by slashes to the actual web page file name. In this case, it shows index.html. It could be index.asp, ASPX, index.cfm for Cold Fusion, etc. So there always has to be a file extension associated with the actual file so the web server knows exactly what it's looking for. Next, you'll see a list of top-level domain names. Again, this is a brief list. There are more. Feel free to check those out. Here's a URL to look at different country codes, state codes, city codes for different types of top-level domain names. Again, read in greater detail throughout the chapter. I did explain this a few slides ago about the request and the response, so check that out. All right, as we move forward now, we're looking at markup languages. Historically speaking, there was a language called SGML, Standard Generalized Markup Language. This was one of the first onsets of HTML that was used back in the 1990s. Thereafter, it actually became more visually appealing when we used HTML. This again is using brackets, as you'll see in the next chapter, that give purpose to the text, a semantic purpose. So that way when a header is identified versus a bold piece of text versus a strong piece of text, they all may look exactly the same, but semantically they have different purposes. So we will go through that in greater detail in chapter 2. We also have something called XML, which stands for Extensible Markup Language. This is non-visual. It's not intended to replace HTML. It looks nothing like HTML. It doesn't display like HTML. It truly is a transfer of data between devices. So if you recall back in part 1 of this presentation, we talked about an extranet, where Kraft or Procter & Gamble might be on an extranet with Walmart. And so when we talked about the quantity or the supply or the prices of different products that Walmart were selling on behalf of Kraft and Procter & Gamble, in order for them to communicate in the same language, they would take their individual databases and export or send over a file in an XML format. We can't share databases really easily. It's too particular. There's too many opportunities for viruses and Trojan horses and errors. So what we do is we export that data into an XML file. And that XML file can then be shared with Walmart, and then they compare it against their database export to an XML file. Data can be easily delivered, understood, and compared using XML. If you ever opened up an XML page in a web browser, it literally will look like code with brackets. It's not visually appealing. So keep that in mind. It purely is there to transfer raw data between two entities. XHTML is an older version of HTML prior to HTML5. It was created after HTML 4.0 when we found that XML had some specific requirements of having all lowercase tags, and all tags had to be open and closed. There's some basic things of that nature. So the difference between HTML 4.0 and XHTML was the force or the strictness of a DTD, a data type definition, that we'll again talk more about in the next chapter, that specifies what tags were available to use and how strict we wanted to be about it. The goal of this was to ensure that any website would display properly on any browser, regardless of what browser they were on or what platform they were on. So that was the idea of XHTML, was to get a greater consistent display of website design across different platforms and browsers. That being said, due to just the updates with cascading style sheets and change of tags, it became long and arduous to actually code in XHTML, and your browsers would have to render through a lot of data and information. So moving forward from there, the HTML5 is the latest version of HTML. Again, check out that hyperlink that's there. There are changes for HTML 5.1, but we're still keeping with the same DTD at this point. Again, we'll cover that in Chapter 2. And then obviously we're also working on updates to cascading style sheets and how they play a role in your HTML development. Hopefully this was a brief and quick summary of Chapter 1. If you have any questions, please ask, but I do ask that you do go through the actual PowerPoint, the actual chapter, and read all the pages in great detail so that way you do well and understand all the concepts and material and prepare yourself for Quiz 1 for the chapter. Thanks and have a great day.